Good day again. This is Don Larson speaking. We're ready to get started with our webinar. Before we get started, just a few precursors. For those of you who are not familiar with Larson Software Technology, we're a U.S. company based in Houston, Texas. We were founded actually in 1984 as graphics technology experts and have been doing that for over 30 years. We develop powerful 2D and 3D technical illustration software, plus conversion and viewing solutions based on open file formats. We have promoted for some time the CGM usage by providing a free CGM viewer, TIFF viewer. We were a developer of the first HTML5 CGM viewer to eliminate the need for plugins. We first introduced the first SVG profile for the aerospace industry, hopefully assisting with the standardization of the file format in the aerospace and defense industry. We're focused on developing 2D or 3D solutions for standard-based industry formats. And then just a quick review of the housekeeping rules for the webinar. If you experience any problems joining the webinar or have any problems while we're going, use the questions function to communicate with us. All attendees will be muted for the duration of the webinar, and computer audio is the recommended option. There are associated materials associated with this webinar. There's a little handouts panel, or in your control panel. You can just drag and drop those PDFs to your desktop, and we invite you to do that. Also, we want you to post any questions during the webinar using the questions panel. Feel free to do that at any time as those questions come up, and then we'll answer those questions at the end of our main presentation, or if we fail to get to them all, we'll follow up by email. So with that said, now let me turn it all over to Dave Manick for the main part of our presentation.
Thank you, Don. Good morning, good evening, good day, everybody. Thank you for joining us. Just to let you know, we have had a few technical difficulties over the last couple of days with the platform that we're using. Don literally joined the webinar 1 minute before he actually made that introduction. So yeah, thanks for doing that, Don. Yeah, so if there is anything that goes wrong, please bear with us. And obviously, this is all live, so we are recording as well. So you should be, if you have to leave for any reason, then you should be able to catch up at a later date. So the topic is 3D technical illustrations. We're going to be looking at the workflow, how you would start, create, output, and then finally publish these illustrations in an IETM. We'd like to thank Raytheon today, who provided us with the Eagle Vision product to actually show you something that's kind of real, where the 3D illustration can be seen in a kind of a real life scenario. So this is a bit more of a visual of that workflow. So from left to right, we're looking at importing the 3D CAD data. This could come from various CAD systems. And we'll talk about that in a bit more detail as we go along. From there, we're going into the authoring or the creation of the 3D technical illustration. And we're going to be demonstrating VisX Edit 3D to do that. Then we would output that file into a file format called GLTF or /GLB. Again, we'll look at that in a bit more detail as we go along. But that would be the preferred format, really, to view this in an environment such as a browser, an IETM, because it's lightweight. So you can really put it on pretty much any device. From there, we're not actually going to create any XML today, but we will obviously show the IETM. But both those components would go into the CSDB. So even the GLTF would go in there. It would probably have an ICN number because it's media, or if it's an S1000D project, that is. It could, if it's not S1000D, then it could be named pretty much anything and could be stored anywhere. And then we're managing the data. So this could be a content management system of some type. And finally, we'd actually distribute this information in an IETM where that data is built into something where the maintainer or the end user can view this in a way that enables them to do their procedures and so forth. So the first step is actually getting the data. How do we get it? Where do we get it from? Well, primarily it's going to obviously come from a CAD system, from engineering. So the exchange formats that we support within Visx Edit 3D, we support more than these, but the primary one has been STEP so far. Most organizations will export the CAD data into this format. It's an open format. And it's very rich, and it's got all the geometry really and the model tree that we need to start working with it for creating technical illustrations. So as we move down, most CAD systems we would say will support STEP. Probably pretty much all of them will support STEP. And it's a useful file format because it's usually readily available from the engineering department. One of the main considerations when you start using this data will be file size. So you would really need a computer capable of handling quite large files. We do some optimization on them as we bring them into our system, but obviously to initially use them, you would need a machine of reasonable specification. So we then convert that over from the CAD system into our Visx Edit 3D. So why not can I create this type of illustration in the CAD system? And we would argue that there's some very specific requirements for technical illustrations that really CAD systems don't cater for. Or they might do, but it might be a very complex way of actually doing it. So what we've tried to do is create a tool, develop a tool that's really for illustrators and technical illustrators, technical writers, which makes it very easy then to actually use that data and repurpose it. So to do that, really need those good data exchange options, easy to manipulate the 3D model, isolate the assemblies, explode assemblies and so forth very easily, generate perhaps what we won't cover today, generate quality 2D illustrations from those 3D CAD data. So that would go into like a CGM or an SVG file. And then easily create the 3D technical illustrations, which we're looking at today, by adding value with animations, annotations, etc. And to do that, we'll demonstrate Visx Edit 3D a bit later on. So as a bit of an overview, what kind of illustrations are suitable for 3D? And we think it's pretty much everything that you would do in 2D. So exploded spare parts illustrations, procedural illustrations for assembly, disassembly, scheduled and unscheduled maintenance, repair and overhaul. So pretty much all of those would apply. Even operational, instructional illustrations, and then specialist illustrations that may have some transparency to them to see inside the equipment, cutaways, again, perhaps to see inside with sectional views of the equipment, and then functional illustrations, how does it work? All these probably apply to a 3D as well as 2D. So how do we create them? So in Visx Edit 3D, we can import that CAD data, that STEP and IGES files, and we save them when we bring them in as what we call a .vx3d file, which is our kind of native format. And you would say, well, why do we need another 3D format? Aren't there enough of them on the market already? But the reason we did this is that we can optimize the file size. We can work with them. We can save changes to the file easily, and so we can go back and work on them again, edit them, or if we don't finish them, revisit them and start again and finish the illustration off. So we didn't really find a suitable format. Certainly STEP would not be suitable to do that with. So we created this VX3D file. What we're saying is that you don't output this file. This isn't the file that probably would go in your CSDB. We'd still use the GLB or GLTF, which is our output file, which is the open file format. So VisXedit3D, it provides control over the model, so we can explode it, which we'll demonstrate, animate it, again, which we'll demonstrate later on. And then we need to view it in some way. So we created a viewing technology, 3D, VisX View 3D. It's an SDK, so it's a software development kit. So it's not kind of an off-the-shelf application. It's more something that a developer worked with to integrate it into an environment such as an IETM, so we can view the GLTF or GLB files. And again, we'll explain a bit more about that as we go along. So a lot of people talk to me about 3D hotspots. So it's kind of different because we're all kind of probably familiar with 2D and 2D hotspots where we add kind of metadata to a CGM or an SVG file. The big difference is that the 3D file has a lot of intelligence when we bring it in. So it's almost kind of built-in hotspotting because everything's kind of got a structure to it, but the structure is built in. And that gives the ability for us to kind of interact with it on that component level basis and make it interactive. So in some ways, it's better than 2D. So the additional benefit of that is we get the model tree kind of for free, and then we can see assemblies, sub-assemblies, and we can begin to work with those. We don't have to work with the whole of the equipment or piece of equipment, particularly if it's large. We could just work with sub-assemblies of that equipment. The other benefit is that we can animate this as well. So the data structure really allows us to kind of select those components, perhaps move them, control their visibility, and then transform them as well. Like we could rotate them, scale them. And this is really, again, and this is all in 3D. So this ability is kind of built in. And we'll talk about GLTF and GLB a bit more in a second, but GLTF and GLB give us that ability to capture that animation, record it, and then play that back in an environment suitable for the maintainer. So I'll talk about the GLTF. I think it's the next slide. It is. So why GLTF? The main reason we kind of selected this format for our output is that it's an ISO standard, so it's an open file format, which we felt is important for standards-based industries, especially like people who use S1000D, companies using S1000D, that the narrative really is to use open file formats. It's web native, so there's no plugins required for viewing, which is really a good thing, obviously, with security and things like that. It supports animation to be part of the file, so movement, visibility, rotation. It's efficient. It does compress the file down, so it makes the file lighter. It's got good universal support from some of the large vendors such as Microsoft and Adobe. Microsoft is you can actually insert GLTF files or GLB files into PowerPoint and Word and so forth. So we really think that gives everything a future proof that this format is going to be around for a substantial number of years. So that was the other reason for choosing it. You probably heard me say GLB. So the GLTF and GLB are one and the same thing. It's just a different way of actually saving the file. Oh dear, my audio's gone. Don, could you just reinforce that you still can't hear me? I'm talking at the moment. Okay, I'll carry on talking. Hopefully the audio returns. As I said, we've had some technical difficulties today. So just moving on to S1000D and what the stance is from S1000D on 3D. There is a chapter in the current spec. It's kind of a bit outdated, but there is no 3D file format specified as well, and that's why we really selected GLTF. Okay, very good. So the next part really is a demonstration. So I'm going to go into VisEdit 3D. Hopefully you can all hear me. And we'll just go through the process I've just outlined in the previous slides. And okay, so let's just go to VisEdit 3D. So this is the interface. We've tried to make this as easy as possible to use, as I mentioned earlier. This model is fairly large. It's not an enormous model, but I've just brought it in for expediency, just to for the webinar. So this is the whole of a front suspension unit. I can move this around so pretty easily. I can zoom in. So it's pretty easy to use the model, even though it's quite a large one. So at this point, I could say I want to select a particular part. So you'll see on the right that that part is highlighted in the model tree. So any part I click on here, then that's going to be highlighted. If it's part of an assembly, you can begin to see, this is on the right, that you can see the whole of the part subassembly here, which you then could use perhaps in a separate illustration. And I'll show you how to do that next. So I'm going to use this particular one here, which is part of the differential unit. So if I select this level here, now I've selected all the differential. So what I could do at this point is just say right click, and I can save that as a VX3D file. And I'm going to put it onto my desktop. I'm just going to change the name of it slightly so I can recognize it and save. Okay, nothing really happens here, but if I now go to File and Open, I should see that file I just saved, and I can open it, and I'll now just see that particular part. So you can see this is there's actually one other sub here below that, but if I click, I should be able to see the parts highlight again on this side. So now I begin to work with this kind of smaller assembly within VisEdit 3D. So let me just move this over a bit slightly. What to do? Okay. All right. So what I'm going to do here is I'm going to. I could actually change the view. Let's just say I want to choose another view. I could just move it around, and we've actually built in kind of isometric because we still think that's relevant. So let's just move it to this angle here. And say I just wanted to explode this model. So I can create a new explosion for this. So this might be used in a kind of a 3D spare parts catalog, perhaps. And I move into this panel here. So I've got some options. I could move parts individually, or I can say I want to move these automatically. So I'll just zoom down a bit and then pull these away. So I can nominate the axis to pull away on, which in this case is the x-axis. So I can just keep pulling these away. And then I can still reposition them. So I can say move, and I could move individual parts on here as well. so I could begin to separate them out, or however I'm going to use this. So I can just pull these parts and then move it along that grid line, so I know they're all okay with the grid. So I could just keep pulling them. So I think you get the idea that it's quite easy just to move these parts and pull them away. So that kind of auto just gives me that ability to begin with to kind of separate everything out, bolts and so forth. You can see all the bolts there. And then if I save this, then that saves it as a particular explosion. So if I go to manage, I then can go back and I can revisit that and I can edit it, carry on, or I could create multiple views of this one assembly and choose the one that's correct for my particular use case. So hopefully you begin to get the idea that it's big models, I can break them down, I can begin to work with the sub-assemblies and so forth. Okay, so what I'm going to do next is I'll just cancel this for now. I'm going to import another model similar to this one, just to show you the animation part. So this also gives me the opportunity to show you the supported import format. So as we mentioned, there's IGES, STEP, VRML, GLTF, and OBJ is the latest. And we're going to be adding more as we go along. But I'm just going to say STEP, and I'm just going to go to demo folder here, and I'm going to open this. So this is a similar file to the one I've just used. It's a bit more attractive, it's got some color to it. And this time I'm going to animate as opposed to explode. So same kind of theory, I can actually now move things, but actually capture that movement. So I just use the animation tab. I'm going to say new. And because it's probably going to be a procedure, we automatically name this. And you can set this up however you want, and you can change this name. But this would be step one of this procedure. Okay, totally. Okay, so I'm going to select this part here. Now, at the bottom, you're going to see this timeline. And that part now I've selected, it automatically adds to the timeline. And I get some directional arrows. Now I could just move this. I have other options which we'll look at in a second, but I'd say I just want to move this away from the main assembly and apply that. So now we've not only moved it, but we've captured that movement. So if I go to the play button, which is on the timeline, I should be able to just see a preview of what I just did. So this is taking 2 seconds. So what we've done is created kind of a default time, but you can still go in, you could edit this and drag this along to make this make it 3 seconds if you wanted to. So it takes a longer time to actually get to that position. So it's going to go the same distance but slower. So you can still edit the timeline. So just put some defaults in there just as a starting point. So I'm going to go to my next step, and this will be step 2. At this time, I'm going to move the bolt. So just to show you, I can select more than one item at a time using the Shift key, which is obviously pretty standard in most 2D programs. So I can drag these away as a group, and again, it's added into the timeline, and I can apply that again. So this will be step 2. Next step is obviously 3. So what I was going to show you here was I was just going to select all these 4 items again. And instead of moving, I was going to fade the items. So what that means is that they will actually disappear on that step. So I can apply that. And now next step again, that gives me some space to actually move this item into and apply. Okay, and create another step. And this time I'm going to move this item out here. So you can see this particular one is on a kind of a perpendicular axis. So I can use center axis to move this. So it picks up the axis of that. Again, apply. Okay. So now I'm going to finish, and we should see all those steps now in our Manage Animations dialog. So I could play all of them here at this point. So this should actually play all those particular steps. So the bolts come out, they fade away, and then 4 is the main, and then there's the perpendicular. Okay, so one of the things we built in is the ability to create a reverse of this. So if I've got step 4, 5, I can create a reverse. 3, that was the fade, so I probably don't want to create a reverse of that. And then step 1 was obviously the first one. And let's play all again. So this was one of the things our customers suggested, that they wanted to obviously disassembly, but also to assemble all the components again. So now it should reverse back. And we can reorder these. There's a lot we can do in this dialog, but to get the finished article. Okay, so now hopefully you've seen how we can create that animation. Apologies for the technical difficulties. I'm going to go back to the slides. Oh, sorry, one thing, let's just go back. So now once I've got this animation, I would export, and I would export as a GLB file. The reason we use GLB is it's a binary file. Everything is contained within that file. And that will include all those steps that I've created as well, which would serve as IDs when I want to link to my XML. So that's quite important, as you'll see as we go along. Okay, so that want to give you an overview of how do we publish this information. So how do we then make it available to the maintainer? So the kind of 3 essential parts. One, we've just created that GLB file in VisX Edit 3D with the animations and so forth. The other part would be to create your XML. I'm not going to show you that today. So that could be done in any XML editor from different vendors and so forth. Kindly, Raytheon have made available a demonstration that they've done. They've integrated the final part. They've integrated Visx View 3D into their IETM called Eagle Vision. But this could be integrated into any solution from any vendor that kind of supports S1000D or is distributing their information within a browser environment. So it works with any kind of HTML browser. So it doesn't even have to be an IETM. It's just that we wanted to try and show you something real today, like a real life example. So I'll show you the procedure in the demonstration, but basically this would be your XML on the left. This is just an extract perhaps from that. You can see that when we click on the hyperlink, which will be here, then this event is triggered, which would be step 1. And step 1 is really the that ID that I created when I create the animation, and that resides within the GLB file. So we can then access that, and then when we click that step, that part of the animation will play back. So what do we think this means for really distributing 3D information? Well, there's no plugins required. It's really native to the it's just native to the browser. There's no hopefully there's no software installation required. Shouldn't be any versioning issues, and there should be no security vulnerabilities as you would with ActiveX controls, the old technology for plugins. And that means that you could deploy really on any device. So desktops, laptops, tablets, phones even, if you've got enough collaterals on your screen. So what I'm going to demonstrate next really is really the GLTF within a real environment, which is Eagle Vision from Raytheon, where they've integrated our VisXView technology, our viewing technology, to view this 3D file. Okay, so oops. So let's just go to that next part. So this is the interface for Eagle Vision. This is just our home. So this is where you would be, all your kind of publications would be visible. They've just got a few examples ones here, which is for instance, the bike. So all the data modules are down the left here. I'm just going to go to one particular one if I can find it. I think this one here. So this would be more your traditional kind of 2D illustration, kind of spare parts in a way, or it could be a procedure. But this would be your CGM or SVG. You would click and you can identify the part, or you could go this direction. So a lot of you are probably familiar with this already, is you can have interactivity between the 2D using CGM or SVG. And that's obviously a technology that's been around for some time. So you can have that interactivity built in when you hotspot a 2D file. So this is really the vehicle to view that. So I'm not going to give an in-depth demonstration because I wanted us to move back to the home button. And here we've just got a very kind of simple demonstration of that 3D data. So if we just go back here to the data module, and you can see there's the model I've just been demonstrating, but now we're in the ITM. So this is a procedural, it's just a sample. And here's the steps. So if I click on step 1, then we should see that move away. This is slightly different to the one I did. There is no fade in it, but the bolts do come away. And step 3 would be things. So I can zoom in on this, I can move this around so you can see that it is 3D. The next step, which I didn't show, is that you can change the camera angle. So you can build in a camera. So if you want to actually view from a different angle, that's really straightforward. If we can just manipulate the model within VisX Edit 3D, and you can capture a new camera angle. This is just going to remove that gearbox casing. Then we move a whole series of parts away at the same time. And again, the same. So you don't have to move individual parts. You could, as I said earlier, you could select groups of parts. And I think this one will show that we can rotate within the animation as well, and even highlight it if you need to with a different color. And we've now built in light flashing as well, so it really highlights it to the end user as well. So that's really a demonstration of what you can do once you've got the 3D. It can go into a kind of a real life kind of ITM for the end user. Okay. So I'm just going to summarize what we've been through. So 3D illustrations, I think they really do provide a lot of value. The 3D data provides a lot of value, gives us some easy to work with interactivity, really purely down to that built-in data structure. GLTF and GLB is we think it's an ideal file format for distributing this information. It's light. It really optimizes that. It can contain kind of things like animations and so forth. And Visx Edit 3D really gives you the ability to create those easily. Browser-based viewing. So again, GLTF, GLB allows us to do that. Hopefully, brings down barriers to adoption. So integration with IETMs, S1000D IETMs is possible. And we can also, I would kind of recommend, if you're looking at this, is to start with a pilot project. Look at something that might be appropriate if it's difficult to convey over a particular procedure, that it might be good to show it in 3D as opposed to 2D. So that could be a good starting point. So what we've seen today is Visx Edit 3D for creating the 3D illustrations. Visx View 3D is the SDK that allows the integration within an IETM or just the web browser. So you can contact me about that. We've seen Eagle Vision kindly from Raytheon, who provided us with that demonstration. So thank you to them. We'll actually distribute these slides, so if you can't make a note of that particular address, then you can find more details there. But just to emphasize, Visx View 3D can integrate with any kind of IETM. Okay, so I'd encourage you, if you've not asked us a question, please put it in the questions panel. And I think we have a few questions already. I don't know if Don wants to join us. In fact, I think Don had some difficult. Oh, he's back.
Yeah, I'm back. Right.
Yeah. So we had a few technical difficulties as we kind of predicted. So the reason I went very hesitant halfway through was the fact that Don couldn't hear me, but apparently you could still hear me. So that was didn't go very well. And obviously we had a difficulty with the software for some reason, which I don't know. So one of the first questions is, can Visx use Lattice .xvl file formats? And I would say no, because I believe, Don, that .xvl is a proprietary format. Am I right saying that?
That's correct. It is a proprietary. It is a lightweight format. In other words, it was made for a proprietary format that was evidently before the time of GLTF existed. It was created to be a lightweight proprietary format for publishing, but unfortunately we can't read that.
No, and the reason we can't read it is it's proprietary. So what you could do from Lattice, though, is probably export in a different file format that we do support. So that's a possibility.
Yeah, like Vermo would be a good
VRML
too. Yeah, right.
Okay, can Visx animate rigged or linked processes such as gears affecting levers? In theory, yes, you could do that. So it's a good question. It probably depends on the complexity. So you could certainly animate the gear so it looks like it's actually meshing with the other gear. Then to push something, again, I think it would do it, but we'd need to kind of look at the scenario. One thing I didn't mention is that all the software you've seen today is available for your evaluation. So you can always try it yourself. So if you've got particular examples you want to try with, just contact me. I'll put my email address back up, and we can send you an evaluation version for you to try it out. We'd always encourage, any of our software is always available for evaluation. So the next question is it compatible for all CSDBs out there? I would say yes, it is, but it depends what you really want to do. CSDB is probably all that is for managing data. So really any image or media file could go into a CSDB if it managed as an ICN number. So you'd give, say, these GLB or files an ICN, and you can manage it. The depth of management will obviously depend on your CSDB. So if you wanted to view the file, like a preview of it, then you'd have to build in a GLB viewer within your, or the vendor would, which we have companies that have done that, including Raytheon and others as well. So really, yes, you could manage them. It's not probably going to give you abilities to check in, check out, but that's probably true of a lot of graphics files within CSDBs. It's mainly XML that gets that. So the answer is yes. That does take me back to, I think, halfway through when I thought I'd lost my sound. I went on the S1000D slide, and I don't think I mentioned the fact that there is no specified 3D format from S1000D. I'm not really sure there ever would be or will be one either, because of the amount of work required to actually put that into the specification. So what we've done is really select something that's an ISO standard, that's an open standard, that would fit really well with the specification, and something you could document in a business rule on your particular project. So the next question, how would it manage heavy revisions? You would really manage the revisions within VisX Edit 3D, and then you could upload those back into the CSDB. So you could obviously issue ICN numbers with the within work or whatever. So it's not quite the same as managing XML. So any kind of media, any illustration is slightly different to managing XML data. It really depends on the CSDB that you're using and some of the functionality within there. Okay, so I think that's the end of the questions. Yeah, I must apologize for, we had some really a bad lead up to the actual presentation today, so everything's been a bit kind of, usually it runs very smoothly, but today we had some issues, so I apologize for that. There is somebody else who's going to be a recording. Hopefully there will be a recording. It's still saying it's recording. I'm hoping it has recorded this session. And everybody who's attended or not attended will get a notification tomorrow about where you can get to that recording. So we do have a YouTube channel where you can get other recordings of previous webinars. So we will be posted on there, and we'll post a link in an email to you tomorrow. So yes, you will be able to get the recording. And that will have, we won't edit that, we'll actually send it out as it is. So, okay. So thank you everybody for attending. Yeah, apologies again for, I hope it didn't stop your enjoyment or getting something out of the webinar today. Please contact ourselves with any questions you might have. If you want to evaluate any of the software you've seen, we'll be happy to do that. So thanks again for attending, and enjoy the rest of your day. Thank you very much.